Hello, my name is Jackson Syrat, and my student number is 4093259. Here's the evidence for it, right here, the card. Today, I'll discuss how I'll be solving 1.1 of assignment 3. It asks us to display the basic information of the memory dump, as well as determine any suspicious processes in the memory dump. To do that, we simply need to, hold on, let me just go into the correct file, volatility. Okay, to get the basic information of a memory dump, for example, A3Q1 memory.image, that's the memory dump we're working with right now, we use the command python 3 vol.py.f, and then the name of the memory dump, which is memory.image. We got it wrong here. There we go, memory.image. And then we click windows.info. With that, we'll get basic information of the memory dump. Due to time constraints, I will not explain what each section is, just that we have stuff like the major version and minor version, the number of processes, as well as system build number, which is here, with all that stuff. But time constraints restrict me from going into detail. Next, we must find suspicious processes. We can use the PS scan and PS list. The PS scan is used to extract processes that were captured on the memory during the time of capture. We will store it into a separate file for now. Let's call it A3 PS list.txt. And then we'll do it again, but for this time we do PS scan. PS scan is used to extract hidden as well as deleted files, not files, processes on the memory during the scan. Now, this also includes regular processes captured during time capture. To determine the hidden and deleted processes in the memory, we simply need to compare these two files. So by this logic, we can assume that as long as the pscan file has more processes than the ps list file, we can determine that there exists hidden or deleted files. Let's just get, we use this command to extract the number of processes, which is 65. We do the same with list. 65. They both have 65 processes, which indicate there is no hidden or deleted processes. With that out of the way, we must then just look manually in the normal processes with cat. Here we got the list of all the processes in the memory dump, or non-hidden and non-deleted. Due to my limited knowledge on processes and what they do, I had to manually look through research what each of these processes do and if they're normal. Due to time constraints, I will not go through the process of examining each and every process, but I'll give an example. I would I'll choose a file, for example, let's say dlhost.exe, and then I'll go to online, dl explain dlhost.exe, and I get information such as the location and what it does, for example, where it should be stored. Another thing about suspicious files is that they're often pretend to be normal files by having the exact same name. One method to distinguish from suspicious files from normal files is to research where it's being stored. Do research where a process is being stored or the file path of the process, use the command python vol .py -f, the memory dump windows dll list dll list, but with capitals. I'm gonna get rid of this list and do PID and insert the PID of the process you're trying to investigate. In this case, it is DL host, which is 2532. and that gives us information on where's the file path of that process. Right now, it's in Windows System 32 DL host, which is exactly where it should be. Therefore, this is not suspicious. Again, I will not go through the process of everything, but I will explain what I found out during my investigation. I found out suspicious processes, which is if I could see it here, netstumbler.exe as well as FTKey imager. TFKey imager is used to create disk images, and netstumbler is used to scan the network for LAN and all that. Normal people or normal users will not need or use these processes, which make it very suspicious. A threat actor can hijack uh, a user's computer and use these processes to gather information about the host's environment, as well as gather information on the host's disk using FTK imager, making this very suspicious. And that's how I investigated the memory dump and gathered basic information as well as determined suspicious processes on the memory dump. And that's how I solved question 1.1 of assignment 3.